down, so he made him not no. Yeah, he got ruined. He got ruined. You know, at first he was pretty good, but now he's like sensitive little baby boy. Why? I feel like he got ruined. Like he's great. He's miles. He's the best character out of all of them. Like he's miles better than famous. And all of the characters kind of. Okay, maybe not where they are. Tam and what his sister. She's actually pretty beautiful. Like the most annoying thing though is that the fact that the author only focuses on
all right, we are Science 9. Did I turn on the projector?
Not. Oh, that was just for
Are you coming on? Oh yeah. Okay.
Oh, I mean, this is
We are going to be on page 103.
okay, I like this one. These two are
Okay,
yeah.
103. Ladies and gentlemen, if your book is not open to page 103, could you please turn there now? I'm sorry for the delay. We had a little moment there, but we are now up and running. All right, so which axis do we graph the independent variable on? Hold on. I'll see it later. We put the independent goes on the X. You were thinking of the dependent because they sound so much alike, right? Yeah. The dependent goes on the Y. Okay. What is the other word we can use for independent variable? What can we use? Manipulated. And what can we use for the dependent variable? Responding, yes. Okay, little review of your vocab there. This particular experiment was actually one that my dad did when I was a teenager, and he was teaching at a different high school. And we had a beagle, and he would bring the beagle into school, and they would attach this like ticker tape to him, and they would hold a treat at the other end of the classroom, and the beagle would run, and they'd see how fast he could go in a certain amount of time. Okay? So they would see how far did he go after 10 seconds, how far did he go after 20 seconds, etc., etc., etc. What in this case is the independent variable? And what is the dependent variable? Have a chat with your neighbor about that. When we're testing this, what is the independent variable? What is the dependent variable in that experiment?
The time that's right? Yeah, it's the time. So, because you change the time, right? To see how far the dog can get. No, you like attach like what I understood is that you have the like measuring tape, and then you put a 10-second timer and see how far they go off. And then you do a 20-second. Okay, yeah. So then the end would be how far they go off. Yeah.
Okay, what do we think is the independent variable? Independent variable is time. Now, in almost any instance, if time is one of the variables, it will almost always be the independent variable. okay? If time is one of the variables, it will almost always be the independent. Not always, but most times. What is our dependent variable in this case? Distance. Yep. So how far the dog goes depends on how long the time has gone on. Now, the plural of axis is singular. You don't have to write this part down. Axes is plural. So, in science class, and probably in math class as well, you'll be always told to label your axes. Label your axes. But I found this little joke online, a little meme about label your axes. We have a light axe, we have a heavy axe, we have a double axe. Thank you for faking a laugh. I like that. A+ for you, my dear. A+ for you. All right. Remember, when your teacher tells a joke, always fake a laugh. It's good for their self-esteem. And then a happy teacher is nicer to their students always, right?
It's like not fun.
Well, you can be like,
I don't think anyone can get that.
alrighty. Because sometimes, I know my jokes are not amazing, but I try anyway, because they make me laugh. All right. So what is going to go on our axes is going to be the name of the variable. So you have to name it. And you have to give the unit, both of those. So remember, the dependent variable goes on y. Dependent variable goes on y. We've got that right here. And the independent variable goes on the x. And in our little dog running experiment, what was the independent variable? Time. So we're going to label this axis, and we're going to leave some space, because very often what we'll have to do is we'll have to put little ticks on here and start numbering them. So we need to leave some space for numbers. Okay, so don't write time right up here, because otherwise you've gotten in the way of writing your numbers. So we're going to write time just a little bit lower, time. And then the units go in brackets. Okay, and time for a dog running is probably measured in seconds, because especially if we're just running across a room, it's not going to take them that long. So we have time in seconds is our independent variable. Our dependent variable is distance. Now, I'm going to write it sideways so that you learn which direction to write it sideways. If you're writing sideways, you're going to write it up. You're going to write this way. So it's going to be distance. Okay? And then that's going to be in meters. If you have enough space, you don't have to write it sideways. You could also write it just, distance. That would be fine. And then meters. But sometimes you won't have enough space. So if you need to turn it sideways, make sure that it's like you're writing on the axis itself. It's like the axis is the line you're writing on. Okay? You are always going to give your graph a title in one of the following forms, and I'm going to put a box around one of them and some stars, because this is the easiest one. All right, and if you're only going to learn one of them, you're going to learn that one, which is dependent variable. Do you guys know what VS stands for? Versus independent variable. Which axis does the dependent variable go on? The y-axis. You okay? All right. And then the independent variable is the x. So it's also always going to be y versus x. So for our graph, we are going to write it as, here's our title. You wouldn't actually write title, but I'm going to write title so that we know that's what we're writing. What would we write first? Would we write distance first or time first? We would write distance first. If you have trouble remembering that, which word, as you move from left to right across the page and top to bottom, because we read like this, right? We read like this. Which word do you come to first? You come to distance first. So which one comes first? Distance comes first. What do you come across second? Time. So time comes second. So you're going to write, and I'm going to get rid of all these because they're not useful. Distance. And then what goes in between distance and time? Versus VS. Time. And then if you want to get descriptive, you can say something like, for a dog running. This part here is optional. Later on, you might get asked to always write more specific stuff than in grade 9. If you get y versus x, dependent versus independent, I'm going to be a happy camper. If you want to try out any of the other ways of writing it, you can, but they switch around, right? So I'm just going to say stick with that one. Stick with this one. That's the guaranteed money winner. Okay. You need to choose a good scale. What does it mean to choose a good scale? That means when you're going along numbering along the bottom, let's say, don't write this on, okay? I'm just going to give you a couple of examples. Let's say I started at 0 and I went 2, 3, 7, 10, 11, 12, 22. Are we liking those numbers? No, you always have to go up by a consistent amount. You can't go up by 2 and then 3 and then 1 and then 7. It has to be consistent. So you need to you remember doing skip counting when you were in elementary school? Okay, you always got to be skip counting. So you're either going by ones where you're like, it's 1, 2, 3, 4, 5, or 2, 4, 6, 8, 10, or 5, 10, 15, 20, or 10, 20, 30, 40. Okay, so it always has to go up by a consistent amount. So a consistent amount, skip counting. Okay, so 2, 4, 6, 8, 10 would be good. 2, 3, 5, 6, 10 would be bad. So this one's good. This one is bad. Oops, I erased by mistake. You want something where it's going to be easy to approximate values in between. So good scales to work with are usually 1, 2, 5, maybe a 4, because half of 4 is 2 and a quarter of 4 is 1. Okay. Or you can use things that have the 1 or 2 in them. You can say, oh, 0.001 or 0.002 or 0.2. Anything with a 5, a 1, or a 2 in it are usually good intervals to work with. Can you use an interval of 3 or 7? Yeah, or 6, but it makes your life harder because then you're trying to, say you've got something this big and you're trying to divide it into thirds. That gets harder, right? What if you're trying to divide it into sevenths? Try and avoid those weird numbers. Like, it's really hard to be like, I've got this thing here, and this is 7, and this is 14, and then I have to be like, okay, so where is 9? I'd have to be like, oh, 1, 2, 3, 4, 5, 6, 7. Oh, dang, that's wrong. Do you see how it's just hard to figure out where the numbers are in between? Okay, so, but if you did, this is hard, but if you did something like 0 and 10, you'd be like, well, I know 5 is there, right? And then you'd be like, well, 5 isn't that hard to do. I can do like 1, 2, 3, 4, and then we're good. Okay, but you get a number like 7, it gets hard. So this is easier. You are always going to make a scatter plot unless it is obvious that you should use another type of graph. So it's always going to be a scatter plot. But yesterday, during the POGIL, you learned about a different type of graph. What was it? It was a bar graph. And if you have a situation where you should use a bar graph, it should be obvious to you that you should use another type, like a bar graph. And I would like you to tell your neighbor what you remember about when you should use a bar graph. Thank you so much.
Yeah. Anything else?
No,
Okay.
just chill. Okay, when should we use a bar graph? Okay, yeah, try it.
Comparing like one, when you only like using one variable and you're just comparing, I guess.
Yes.
When you only have one variable, basically.
When basically it's when you have when you're comparing different groups.
Yeah.
Okay? When you're comparing different amounts of different groups. Like, how many people in this class are between, 4'6" and 5 feet tall, right? And then how many people in this class are between 5 feet tall and 5'6"? That would be a good bar graph, because now we're looking at groups of people. People who are this tall or this tall or this tall, and we're looking at numbers. You are never, ever, ever going to play connect the dots, because you are not children anymore. Oh, it's so sad. Childhood is wonderful, but you don't get to play to connect the dots. Not unless you go into finances. If you're in finance, you can watch the stocks go up and down. But generally in science, we're always going to be drawing the best smooth curve. And the weird thing about the word curve is that scientists use it when they mean either a curve or a straight line. I know, it's strange. So we're basically drawing the line of best fit. No connecting the dots. Your data. Your data should be graphed as large as possible in the space. Okay, so if I give you a piece of graph paper that is this big, I want it to take up at least, like, that much of the page, right? I don't want it like all crammed down in one corner or up here. It should take up a large chunk of the page. Here is an example of a bad graph. I would like you to look at that with your neighbors and tell each other what is wrong with this graph.
Okay. Connect the dots. That's wrong. Yeah. No connect dots. Why is it jumping in 40? What else? There's no labels.
What's one thing that's wrong with this graph? We're connecting the dots. Do not connect the dots. What should we do instead? Draw the trend line, the best fit line. What else is wrong with this graph? Yeah? There's no title. Anything else missing? Yeah, why is the 0 like floating up here? Why would we not put 0 down at 0? There's no labels, yeah. Is there anything they did do well on this graph?
Numbering, I guess.
Yeah, the numbering. It's consistent scale. It seems like they're fairly normal values. Okay, that they did the numbering all right. Okay, let's check out and see if we missed anything on the next page. What's wrong with it? There's no title. What is it a graph of? Who knows? There are no labels. There are no units on the axes. So in addition to the label, you would want the unit. Somebody played connect the dots. Why is the 0 not at the origin? Why is it starting way up where it does? Why is the graph so small? Let's fill our space. So here's a better graph. This is the same graph, same numbers. I still need to fix this because the 0 still isn't down at 0. I need to fix this. I got it closer, but I didn't get it all the way down to 0. But now we know that the bottom is the automobile speed in kilometers per hour. We know that the dependent variable is the cost of the average speeding ticket. And we've got it titled The Dependence of Traffic Ticket Cost on Automobile Speed. You could also write that as traffic ticket cost. Remember, what do you come across first when you're reading? First, you come across the cost, and then you come across the speed versus speed. Doesn't the clarity and beauty of this graph make you want to cry? Doesn't it? No. But does it make more sense than the original one? Yes. Okay. Out of these two graphs on the next page. So we are now on page 106. Which of these two graphs is more correct and why? Tell your partner, discuss with your partner. A or B? Which one is better? Boys, which one is better? Graph A or graph B? Chat amongst yourselves.
It's a little weird. Yeah. 2, 4, 5, 10, 12, 18. Yeah, my favorite way of graph it.
What do you guys think, A or B? Oh, A, actually, here we go. Remember, the sign for A is like that. It's an apple with the stem, okay? And B is you put your palm and you put your thumb on your palm. So let's all do A. Everyone show me A. And let's all do B. Everyone show me B. A again. B again. C. Ooh. D. Point your finger up and all the rest touching each other. There you go. Point your finger up. No, that's your pinky finger. Not that one. Okay. All right, but nice try there. I saw that. I got you. Okay. Which one did we like better? A, because we go up by 5, 10, 15, 20. That's some nice skip counting. Whereas 2, this goes up by 2, it goes up by 2. This one goes up by 1. This one goes up by 5. What's happening here? 2, 6. That's crazy. Okay. What type of correlation do we have here? In graph A.
It looks like it'd be perfect.
You know what I'm going to do? I have these lovely cards and they have everybody's name on them. And I'm going to shuffle them. And what I'm going to do is I'm just going to draw a name. And it's totally okay to just say pass. Like if you're like, I don't know, or I just don't feel like talking to you today, Ms. Spence. That is okay. You can say pass. All right. But it's about getting out of your shell a little bit.
Wait, Ms. Smith.
Yes. What we're doing is I'm going to draw a name. Okay, I've got all your names on these little cards. And you're going to tell me the type of correlation. But before we do that, I'm going to let you chat with your partner. And if you're partnered and you don't have an idea, then talk to the person in front of you or behind you or somewhere so that you feel confident when answering the question. What type of correlation is graph A?
I did the line first.
Anyone need more time? Nope. Okay. First one goes to, oh, and I spelled it wrong. I'm so sorry. I have to make you a new card. Kira, what kind of correlation do we have here? Yeah. Positive. But I got to make you a new card because I spelled your name wrong. I did them at the beginning of the year before I knew you so well. All right. And there's another descriptor we could also put on here. Does anyone want to give me that? Or not? I thought I saw your hand up first. That is positive. Perfect. Okay. Very nice. Perfect positive correlation. Now, all the graphs we have looked at so far have been what we call linear. That's because we can make a straight line. Straight line.
Miss, there's something wrong with the graphs. Yeah, there's no type.
Oh yeah, there's other things wrong with it, but I just wanted to know which one was more correct. Okay, so if we get a straight line with our data, it's called linear. But sometimes your data will not give you a straight line. Sometimes it will give you a curve. Your curves, however, will be smooth curves. You're never going to get like wiggly woggly all over the place. No wiggly woggly all over the place. Smooth curves only. If you are interested, I've put in like what some of these are, if you're into math. This one starts slow and it gets steeper and steeper and steeper and steeper. This one starts going downhill slowly and then goes downhill faster and faster and faster and faster. This one goes uphill fast and then it goes uphill, but still slower and slower and slower. This one goes downhill fast and goes slower and slower and slower. Do you see, though, that they are smooth curves and then they're not just wibbling, wobbling all over the place? There is also this special one, which looks like the letter S. And it's called sigmoidal because the Greek letter sigma is an S. I know, it's so funny. Sigma. Skibbity toilets and 6 and 7. Oh my gosh, life is so funny. I can't handle it. My jokes are funnier than that. I swear they are. Okay. So let's look at these sample problems on the next page. You guys are going to try these on your own. These are either going to be linear or they're going to be non-linear. They're going to be a curve. So you are going to draw either a smooth curve or a straight line. And to aid in drawing the straight lines, I will get you guys rulers. Do you want to grab rulers? Yeah, start handing them out and then I'll help you in just a moment. Once you have drawn a smooth curve or a straight line through it, you are going to write it as either linear, you can just put L, or non-linear, you can just write N. Okay, so you're going to do all of these on this page. Give it a try. No, that one did. Folks, for the first one, somebody played the connect the dots, you're gonna fix it. This one here, somebody played connect the dots, you fix it so it's better. Okay?
I didn't understand that deflation was bad. Yes. So this
From here? Okay.
You can go get water, yeah. Now, you don't have to be straight line. Folks, they don't have to be straight lines. They can be curved. So take a look at the curves on the previous page and see if they fit the data better than a straight line, okay? Oh.
That's the immersion. Yeah. It has
No worries. Good. You see which one works the best? That's straight line. Got it. Yeah. I think that's true.
Wait, is multiplying, what are they called, negative numbers, basically the same as like plus number multiplying?
Okay, we're gonna go over these. And I should put this first one last because it's actually one of the harder ones. If you go back to the previous page, and if you open your book, you'll see both pages at once. That first one kind of looks like this. Yeah? So I would tend to make my data do this. Kind of. Okay? Probably that would be my best guess. This next one, does that look like a curve or a straight line? The second one, the green. Straight line, yep. So once again, you can eyeball it, which means you just put your ruler down as best you can into the middle of those points and draw the line, or you can draw your blobby shape, saying where is the middle of my blobby shape, and that's pretty good. All right. What do we think about this one here? Is that a curve or a straight line? I think that's a curve because it starts steep and then it finishes shallow. When you're drawing a curve, you still try to have the same number of points above as below. Sometimes it's hard to draw, just do the best you can, okay? How about this one? Straight line or curve? I feel like it might be a curve. You could argue straight. You could argue straight. Okay, I'm not going to say it couldn't be straight, but I feel like it is more of a curve. Okay? If I were to give you something like this on a quiz or a test, I'll make it one of the more obvious ones. Okay? How about that? That's got to be straight. I don't see any other trend other than just throw that through the middle. And then this last one, what shape is that? Does anyone remember the name? Sigmoidal.
I think it's basically impossible for anyone to forget that.
Yeah, if you can't figure out that shape, then you're like out to lunch. Yeah. Okay. On our next page, what do we call those points there? Those points are called, and this is something that everybody always forgets, but these are called outliers. They lie outside of the regular data.
Wow.
This particular one, we've got knee diameter versus ankle diameter. So these people, I don't know. I guess they've just got very thick knees. I don't know. Yep, you never know. Do we have any outliers in this data set? Where would our outlier be? The one at the top is actually really close to the line. So this is not an outlier. It's on the trend line. It's close to the trend line. Probably this one is an outlier. It's not a huge outlier compared with some of the others, but it is a bit outside the data. Okay. You now are going to draw a best fit line for this and circle any outliers. Circle them and label them. Check with your partner when you're done. See if they got the same as you. Do we need to go on a parking lot walk? Okay, it's probably the last day before it starts raining, so let's go. Okay, parking lot walk, and then we're gonna finish this up.
Okay, no worries.
Take your time, it's all good. Having tight shoes is important. You don't want to trip and kill yourself. Break a knee, turn an ankle, they'll be gone.
so greedy. You have so many Tic Tacs. You literally have like so many. Bro, you eating them like fast? Popping them. No. That's like 5 days. You give me like one. I'm totally
You want some? Yes, he's a bad. Back here. That movie is. Oh yeah.
Okay, friends.
I was really sure.
We've had our walk. We are going to refocus. Do you guys know what the origin is of a graph? The origin the corner of your graph does not have to be 0, 0. Okay? It doesn't have to be 0, 0. Has anyone ever used a break in math? In a graph? No, never mind then. I won't talk about that. But if you look at this graph, here's our page. All of our data is here. What is wrong with that?
It's too tiny.
It's too tiny. You need to fill the space. But how are you going to fill the space? Do not. How are you going to fill the space when you don't have any points down here near 0? You don't have any points until you get to like 150. So what that means is you don't actually need to start your graph until 150. And going upwards, we don't really have any points until after 40. So that means we can actually start our graph at 40. And that's going to allow us to really expand the plotted portion. Okay? So here we are. We're now starting at 40 and 140, not 0, 0. All right? Because none of our data were even close to 0. So it is okay to start not at 0, 0 if none of your data is close to 0. Now, that isn't to say that we throw 0, 0 out the window, because 0, 0 can actually be really important. What is the mass of 0 milliliters of water? 0. Is there going to be any error or uncertainty in that point? No, because you know if you ain't got no water, ain't got no mass, yeah? So if you do know that your 0 point is exact, you should make sure that your line goes right through the origin. The origin is the corner. And if you have a point that is 0, 0, make sure your line goes straight through there. Okay? Let's take a look at this next graph. Should this graph pass through 0, 0? where we have years of experience and salary? No, it should not pass through 0, 0. So you're not going to aim for the 0, 0 point. You're simply going to draw your trend line like that, okay? Don't aim for 0, 0. But let's take a look at this one. The number of times we roll a die is singular for dice. Okay, so you roll the die, and how many times do we get 6s? 6, 7. Okay, if I roll the die no times whatsoever, how many 6s will I get? I will get 0. Should this graph pass through 0, 0? Yes. So what I'm going to do is I am going to, and it's kind of hard to do this, but I'm going to grab this one here. What I really want to happen is I really want this to pass through 0, 0. This isn't quite long enough to do it, but what I'm going to do is I'm going to tilt my ruler up and down until it goes through 0, 0, and it goes through the middle of the points. Does that make sense? So I'm kind of saying, here's my 0, 0 point, and I move it up and down until it goes through the middle of the points. So why don't you guys try doing that? Put your ruler on 0, 0, and then tilt it until the rest of it goes through the middle of the points.
Let's just think through what was the rule.
If you got your line drawn, I would like you to look at that graph and see if you see anything else of note. Is there anything else special on this graph that you could take note of? There is an outlier. Sometimes people forget and they call it an outliner, but it's not lining anything. It is lying somewhere that is not within the regular set of data. Outlier. All right. And now your homework is to do pages 111 and 112.
Here, miss. All right, here.
Oh, thank you. Oh, yes, let's see. Have we, okay. You have forgotten that. Title and we want that.
If you have any questions, you can ask me, okay? And sure.
If you want to redo it, you can redo it if you got the road 21 up to a maximum of 21. That's up to you. Okay.
Wait, I'm still.
I know.
I forgot if it's 3 the first week.
Bigger and nastier.
Okay. I'm coming around to collect a little stuff.
Yeah, I
I feel so good to fix us, but it's actually like the fact that I'm writing later.
Folks, I forgot to put in units for you for the distance and time in one of those. So I need to fix that. You can put in whatever unit for distance and time you want. You could go with meters and seconds, those are a good choice.
It's 3 times 3. Yeah, it's 9. It's 9. It's 9. No, it's 9. So it's supposed to be on the ground.
If there are any questions, I'm coming around, okay? Yeah. Okay.
Yeah, that's what told me from that. It was supposed to be in,
Yeah.
whoa, that was too defensive.
Any questions? Okay.
That's my.
You may get your phone if you'd like to take care of the homework.
On the last section, and then
Yeah, but don't worry if you don't. I know you're always on top of your homework, so if it doesn't happen, that's.
This is 9. Oh my god.
Thank you for asking.
Yay. Yay, that's over here. Well, now I want a chicken sandwich. Yeah. Oh, yes.
Hi. I will be here on Monday because
Okay.
I'm going to go to a funeral.
Okay,
Yeah. So, is there any homework I should do
like
from
Monday?
Yeah, like Monday to like
We might
'Cause I
have
already
like,
finished my
yeah,
homework.
we might have a review.
okay.
And so I'll make sure I have it available for tomorrow
Okay.
so that
That's fine.
you don't miss out on it.
Yeah.
Yeah, okay, okay.
Yes, ma'am.
Oh my god. Yeah. I actually really like this pen. It's really big. All of this is just spare stuff. I already have one of that. I'm gonna go away. I'm pretty. Yeah. Wait, what is it? Oh, yeah.
Today I'm trying on.
Everyone, you can go, it's okay. Class is in about 10 seconds.
Yeah, I don't have to like chatting. But like I
Bye, everyone.
I got 23, okay?
See you tomorrow.
Thank you.
Bye-bye. Everyone left.
I had to just tell him this chat or something before I forgot.
Okay,
Okay, have a good day.
you too. Anything for me to take home? Or...
No, thank you though.
Okay, you're welcome.